Hello everybody and welcome to this, my corner of the internet. I am SDCard and today, as you can probably tell, is the inaugural flight of my brand new microphone. And how else would somebody like myself mark the use of a new piece of tech with an explanation of how it works? In this video I'll explain what sound is, how computers record it, and how computers reproduce sound. So first of all, what is sound in a scientific sense? Sound is the mechanical transfer of energy through a material. Kinetic energy causes particles in the material to collide, transferring the energy. In other words, waves of energy travel through a material causing vibrations. These vibrations are what are called longitudinal waves, meaning that they're made of areas of compression and rarefaction. This is a posh way of saying that some areas of the material are closer together and denser, whereas other areas are more spread out. Longitudinal waves oscillate in the same direction that the wave travels, meaning that the particles move backwards and forwards. This is the opposite of what happens in a transverse wave, in which the particles oscillate at 90 degrees to the direction of travel. In other words, the particles move up and down. However, for mathematical reasons, sound waves are still plotted as a curve. The vibrations are then interpreted by our brains as sound. This is done by a drum of skin inside our inner ears vibrating. This vibration is then passed into some of the smallest bones in the human body, which trigger a nerve reaction. Digital sound reproduction relies on the simplest rule of electromagnetism. The movement of a magnetic field creates an electrical current in a wire. This is the fact that most electrical generators make use of. Most power generators rely on some kind of force turning a turbine. In fossil fuel and nuclear fission generators, this is done by using a fuel to produce steam, which in turn turns a turbine. The rotation of the turbine moves magnets through the coil of wire, which creates an electrical current in accordance with Fleming's left-hand rule. In Fleming's left-hand rule, you hold your hands as shown in the diagram. The middle finger indicates the direction of the electrical current. The forefinger represents the direction of the magnet, with north being at the tip of the finger, and the thumb indicates the direction of the movement of that magnet. In a microphone, a magnet is suspended in a metal coil by a diaphragm, very similar to the inner ear. The sound waves cause the magnet to move within the wire, inducing an electrical current in the wire. This current is monitored by the recording device and recorded as a number in the device's storage. The quality of the sound recorded is reliant on two things: the power in the cable and the sample rate. With microphones like this one, the power can easily be boosted using a power pack. Attached to my microphone at this moment in time, I have a 48-volt power pack that improves the sound quality and also relieves the pressure of supplying power that my laptop would otherwise have. The sample rate is how many recordings of the wire's current the device makes per second. The more recordings made per second, the more complex and organic the sound seems. This also increases the file size. The sample rate also impacts the quality of playback. The higher the rate, the crisper the audio. Think of it like this: your voice is not spiky, it is smooth and organic. However, a computer has to make sense of it as numbers, so therefore it only records certain points of your voice's waveform, meaning it loses out on finer details such as the peak here. Speakers make use of the fact that the law of electromagnetism I mentioned earlier is reversible. Applying electrical current to a wire around a magnet causes the magnet to move. Motors use this by constantly changing the direction of the current in comparison to the magnet, thus causing the magnet to rotate. A playback device produces a current in the wire which moves the magnet, which causes a drum to oscillate, producing sound. All of this may sound confusing, but it folds down to this: materials vibrate, which can be used to create electrical currents. Computers remember these currents and reproduce them in a way to cause movement. Thank you very much for watching this. Make sure to leave your comments below along with your suggestions for what videos I should make in the future. If you enjoyed this video, make sure to like and subscribe, and if you really enjoyed it, make sure to share to your heart's content.